The derivation sheet explores the transition from abstract geometric theory to the physical reality of how objects move and interact in space, focusing on the distinction between static snapshots and dynamic processes. This journey is structured through two primary conceptual maps: a state diagram and a sequence diagram. The state diagram, a path to visual verification. The state diagram outlines a progression that begins with a theoretical foundation and culminates in a visual synthesis of complex motions. From foundation to animation, the journey starts by defining how specific rotations, such as those around vertical and horizontal axes, interact with one another. This theory is then brought to life in a three-dimensional animation that uses color-coded indicators to show how combining two different rotations naturally generates a third, entirely new rotation on a different axis. Visualizing the discrepancy, the narrative then shifts from looking at individual points to observing a physical process. Through a specialized visualizer, the viewer observes a particle moving in a loop. In a simple flat environment, this loop would close perfectly. However, the diagram illustrates that in rotational systems, a physical gap or drift is created. The final synthesis. The state diagram concludes by contrasting two ways of looking at geometry: a static snapshot that merely finds a perpendicular direction and a dynamic process that explains how movement evolves over space. The sequence diagram. The analytical workflow. While the state diagram maps the overall journey, the sequence diagram provides the step-by-step logic required to validate these ideas through a specific workflow. Setup and algebraic comparison. The process begins by establishing two primary rotational flows. At the algebraic stage, a standard calculation provides a static view, a snapshot of the relationship between vectors at a single point. This result points radially outward, like a spoke on a wheel. The differential stage. The workflow then moves into a differential stage, which acts as a process operator. Instead of a single point, this stage measures how the rotational fields change and interact as one moves through them, identifying a new rotational flow rather than a simple outward direction. Mapping and validation. These results are mapped to the broader structure of how rotations behave in three-dimensional space, confirming that the interaction of two rotations is always a third rotation. The final validation occurs during the commutator loop stage, where a